Hello, everybody. We're getting into chapter 3 today, 3.1, solve one-step equations. This entire chapter is all about solving. Okay, we'll be solving first equations that get a little bit more difficult as we go along, and then eventually we'll be solving inequalities. All right, so one-step equations are really simple stuff today, but before we get into this, I'm gonna have you guys try out a quick warm-up dealing with what we were learning in the last chapter. All right, so we're going to be looking at some inequalities, and I'm going to have you check some potential solutions to see if they actually work. All right, so take a minute here, copy down numbers 1 and 2 here, and plug in these numbers into your inequalities and see if they're actually solutions. Okay, try it out. All right, so let's see how we're doing here. On number 1, they're asking us to plug in 4 for A. All right, so let's go ahead and write it out. So we got 4 times, again, we're plugging in 4 for A, minus 5. We have the symbol, and 10. All right, and really, I guess that we should put a little question mark here because that's kind of what we're wondering is if this works. All right, so let's do this math and see what happens. So it looks like I'm getting a 16 minus 5, have that symbol, and a 10 on the right. Right? And it looks like I'm getting an 11. Okay, and yeah, that question mark, let's follow it all the way down because we're wondering if this is actually true. Here's the thing, I'm purposely not saying the name of this symbol because if you didn't immediately know what that was, this problem is kind of a 50-50 guess. All right, is that a greater than sign? Is it a less than sign? That's what you need to know. The math is simple, right? And if you know that it's a less than sign, you can make some sense out of it. Is 11 less than 10? Well, no, it is not. So is 4 a solution to our inequality? No, it is not. Okay, so that's kind of really the point of this stuff. Do you remember what these inequalities mean? Because it's important. Okay, so let's try it out with number 2 here. So plugging in 40 for P, so let's go ahead and do it. 40 over 5 minus 7, some symbol, 1. Okay. Just by the way, we're not solving anything here. We're just simplifying. We're just kind of doing all the math we can. So order of operations applies, right? So we'll do this division first before we subtract. So 5 goes into 48 times, minus 7, some symbol, 1. All right, and it looks like 8 minus 7 looks like we're going to get a 1. All right, and like I said before, I like to put little question marks because really that is what we're wondering. Is that the case? All right, on this problem, again, knowing what this symbol means is kind of the whole point. All right, this is a greater than or equal to symbol. Okay, little equal to symbol on the bottom. Is 1 greater than or equal to 1? It's not greater than, but it is equal to, so it does work here. So our answer on this one would be yes. Okay, so yeah, nice little warm up there. We'll be getting into inequalities in a few lessons down the line here. Okay, but today again is all about solving one-step equations. So get that title at the top of your paper, copy down this problem. I'm sure you can do this on your own, but I'm really going to kind of remind you guys of some good fundamentals here. All right, so copy it down. Okay, so solve for x. I think that's going to be the directions for like this entire lesson, if I recall correctly. So just a reminder on fundamentals of solving. When we're solving for a variable, we're trying to get all of the numbers that are on the same side of the equal sign as that variable away from it. All right, and on this problem, all we have is this positive 7 that we need to get rid of to be able to isolate that variable. All right, you guys remember to solve to get rid of numbers, we need to do the opposite operation. So if this 7's being added, we need to subtract it from both sides. Okay, and remember, both sides, whatever we do randomly to one side of an equation, we have to do to the other side to keep things balanced. Okay, so those are gone. We have an x on the left all by itself. On the right, 4 minus 7 equals a negative 3. Be careful with that math right there. And there's my answer. Okay, if you really wanted to, you could check your answer. Some teachers like to have you plug it back in and see if I plug in negative 3, is negative 3 plus 7 4? You can do that if it helps you. I'm not going to require checking for the most part, especially on these easy ones. All right, take a look at number 2. Copy that real quick. All right, so really the only difference on this problem is our variable happens to be on the right side of the equation. And we do have a number that we need to get rid of to isolate it, right? This minus or negative 11. All right, we need to get rid of it. All right, it's being subtracted, so we will do the opposite operation and we will add 11, and whatever we do to one side, we're going to do to the other. Okay, so it looks like we have a 14 on the left equals, on the right we have this x, the 11s are gone. And basically there's our answer. Though, if we write our answer this way with a variable on the right, I want you to flip-flop it and put the variable on the left. So I'm going to write this as x equals 14. Okay, and you could check that real quick just in your head. If I plug in 14 here, 14 minus 11, yeah, that equals 3. So not a bad idea. Okay, so I'm gonna have you guys try a couple of these simple ones on your own, and then we'll look them over together. Give it a try. All right, so again, a couple nice, easy problems. Let's start on letter A here. X, we need to get it isolated. The only thing that's keeping it from being isolated is this minus 8, so we need to do the opposite operation, and we need to add 8 to both sides. And again, I know this is so simple. This is kind of how this book works. It starts you with like really easy math on the first lessons, and it kind of ramps it up, I guess, like any math book. But this stuff is extremely easy. I hope you're feeling good on this. Okay, but it's good. It's good to remember how to do this. Okay, so anyway, looks like x is going to equal 13. Okay, for letter B, variable this time is on the right-hand side. That's okay. It looks like we need to get rid of this positive 2 to be able to isolate this variable. It's being added, so we will subtract from both sides. Okay. Sometimes, I usually work left to right when I do these equations. It's probably the best way to do it. So I'm first going to say, all right, I got a 4 on the left, bring down my t, 2's cancel out. Okay. So I get 4 equals t, but I want the variable on the left, so flip-flop it. There we go. All right, so let's see, what do we got here? Now, in this example, I guess, first of all, go ahead, copy it down real quick. Okay, same idea on this one. We still have, x. There's still just one number we need to get rid of. But this time, instead of it being added or subtracted, you'll notice that this negative 6 is being multiplied by x, right? There's a little invisible multiplication symbol when they put those things together. Okay, so to get rid of multiplication, we know we need to do division. All right, so we'll divide both sides by a negative 6, and just make sure I'm like double checking because it's early in the morning right now for me. And it looks like we're going to be getting an 8 here. All right, sorry, negative 8, right? Just one thing, just small little mistakes I see ever so often is like when people see, oh, negative 6, I'm going to divide, and they'll like divide by a 6, like this, right? Because they're thinking, oh, I need the opposite symbol. No, it's opposite operation. If you are multiplying by a negative 6, you're going to divide by a negative 6. Okay, so try not to get that confused. All right, copy this real quick. Okay, so on this one, it looks a little weirder, but really it's the same idea. We have a variable we want to isolate. Right now it is being divided by a number, a negative 4. So we need to undo it by doing the opposite operation of division, multiplication. So to get rid of this negative 4 that's being divided, we will multiply by a negative 4. Okay, whatever we do to one side, we're going to do to the other. Okay, they're gone. We have an x. Over on the right, 5 times negative 4, negative 20. And we're done. So good fundamentals right there. Okay, I'm gonna have you guys go ahead and try a couple of these on your own real quick, and we'll go over them in a second. Try it out. Alrighty, so we have this 4 being multiplied by x. Hopefully you first thought, okay, I need to undo this multiplication with division. Okay, divide both sides by that positive 4. So it looks like they're canceling. We get x equals 4 goes into 48 12 times. Okay, letter B. just like that last example, we are talking about t, our variable is being divided, excuse me, by a number. So we need to undo it by doing the opposite, multiplication. Okay, it's being divided by a -3, so we're going to multiply by a -3, both sides. Okay, cancel it out. T's left alone. On the right, looks like -27. Okay, I think we just have a couple more here. This is a quick lesson, but let's see what happens when we have a variable being multiplied by a fraction. How do we get rid of this thing? Okay, take a second, copy this now. Okay, so this looks kind of weird. First of all, we need to get rid of this, -2/7 or 2/7. All right, technically it's being multiplied by x, right? Okay, so normally when we have multiplication, we will undo it with division, right? But here's the thing, and don't write this. If I were to write this like this, divided by -2/7, and if I did that to both sides, right here, 4 divided by -2/7, that's confusing, right? Like, what do we do there? All right. So here's what we're going to kind of do instead. Whenever you need to get rid of a fraction, okay, the same thing as dividing by that fraction is multiplying by the reciprocal of that fraction. Okay, kind of like the freeze, change, flip thing we were doing a few lessons ago. Okay, so instead of dividing by a -2/7, I'm going to multiply by the reciprocal, -7/2. Okay, and just remember, when we do reciprocals, we're just flipping it upside down. If the symbol is negative, if the number is negative, it stays negative when we do the reciprocal. Okay, so yeah, multiplying by -7/2, whatever I do to one side, I'm doing to the other. Okay, and the reason why we're doing this, is these cancel out, just like everything else on these other, whenever we did the opposite operation, we were always canceling things out. That's kind of the point of the opposite. That's what's actually happening right here. If we were to do the math, this is a negative times a negative, so I'm getting a positive, and I'm getting a 14 on top and a 14 on the bottom. 14 divided by 14 gives me a 1. So this is just turning into a 1x, or an invisible 1. All right, which technically when we did this right here, when this -3 and -3, when it canceled out, technically we were dividing those -3s and we were getting a 1t. Okay, but we don't write the 1 in front of the t. Okay, so we just think of it as canceling out. Okay, so yeah, that is what's going on here. Those are canceling and we are left with x on the left. On the right here, we just need to multiply this stuff. Just a reminder, when I have, just a nice clean number like 4 and I multiply by a fraction, technically this 4 is in the numerator of its fraction or its ratio. I could write this 4 as 4/1, right? So when I go to multiply these, I would multiply the 4 times the 7, get a 28. And this 2 on the bottom would just stay on the bottom. Normally, I don't write it over 1 like this, though, 1 times 2 would still give us a 2 here. Okay, but you might notice I kind of forgot something, right? Positive times a negative gives me a negative. So this is a -28/2. So let's go one more step. We can actually divide these cleanly. Looks like we're getting a -14. Okay, so a lot of explanation for maybe a fairly simple problem, but it's good to really know, I think some people might run into something like this and go, oh, I don't know how to do this. Okay, just multiply by the reciprocal to get rid of fractions. It's easy. Okay, so yeah, last thing, I'm gonna have you guys go ahead and try one of these, and yeah, we'll try it together after. Go ahead. Okay, so just like the last problem, we have this variable being multiplied by this fraction, and I need to get rid of it. Okay, it's being multiplied. I could divide, but instead I'm going to multiply by the reciprocal of this fraction. So I'm going to multiply this 3/2 times, or sorry, this 2/3 times a 3/2. Okay, and I'm going to do to both sides. Okay, just technically, this is turning into a 6/6, which would give me a 1p, which means they're canceling out, and I'm just left with p. Over on the right, remember when we multiply this 14, it's being multiplied by the numerator and then divided by the denominator. So 14 times 3 gives me a 42 on top. That 2 just stays on the bottom. And now I can divide these. Looks like P is going to give me a nice clean 21. All right, so yeah, easy one today. Hopefully you were rolling your eyes as you went through this and wondering, Mr. Stone, why are we doing this lesson? Because I gotta make sure the fundamentals are there. Yeah, easy day here, okay? So I'll see you guys in class.